Hello Year 12 Single Mathematicians. I'm just going to continue with Chapter 3. This is about as far as we're going to get this year. So it's 3.3 and 3.4, which is a different type of sequence called a geometric sequence, and we're also going to combine it with geometric series as well. So the definition of a geometric sequence is, well, if you remember arithmetic sequence, it was the difference between consecutive terms was constant. So that meant you had to do a subtraction to work out the difference. For a geometric sequence, it is the ratio between consecutive terms is constant. So the ratio between consecutive terms is constant. So rather than adding or subtracting to get the next term, you multiply or divide to get the next term. And it's always multiplying or dividing by the same number. A geometric series, the word series just means the sum of a geometric sequence. And then some just basic examples would be 2, 4, 8, 16. If you looked at the ratio between consecutive terms, so 4 divided by 2, 8 divided by 4, 16 divided by 8, all of those are equal to the same ratio, which is 2. And then the addition is a series. So this is a geometric sequence, and this is a geometric series. Formulae that you need to know. So the first one is how to work out the nth term of a geometric sequence. So the nth term is this, ar to the n minus 1. Only the r is to the power of n minus 1. Now in a formula you need to know everything. So the un stands for nth term, as you should know already. A is exactly the same as what a was in arithmetic sequences, is the first term. N is exactly the same as what it was previously, so that's a position in the sequence. So if you're looking for the fourth term, n would be 4, so on. And r is the ratio. Okay, they call it the common ratio. So that's new. We had common difference last time, just common ratio this time. So that's the thing you do to get the next term in the sequence. Sn stands for sum of the first n terms. So that is a1 minus r to the n over 1 minus r, or a r to the n minus 1 over r minus 1. Either of those give you the sum of a geometric sequence or series. So that is the sum of n terms. A is again first term, r is common ratio, and n is position again in the sequence, or guess how many terms you're adding up in this context. Okay, so those formulas you need to know off by heart. Now you might notice these two formulas are almost exactly the same. It's just the numerators and denominators have flipped in the second one, and there are times when you pick one over the other, mainly when you kind of want the denominator to be positive as much as you can. So if I had an r value which was bigger than 1, then I would pick this one, But if I had an r value less than 1, then I'd pick this one in order for the denominator to always be positive when using it to solve certain things. So let's see what a basic example would look like. So you've got, find the 10th term of this sequence. So firstly, in an exam, you'd have to decide, is this arithmetic or is this geometric? So the difference between the terms varies, so it's definitely not arithmetic. And if you took the ratio between consecutive terms, it will always be exactly the same, minus a half or minus 0.5, which means it's a geometric sequence. So then you would state the formula. 10th term, so that's nth term. And you want the 10th term, so that's u10. A represents the first term, which is 40, times. You should put r in a bracket, particularly when it's negative. Minus a half, common ratio, to the power of n minus 1. 10 minus 1. And I type that thing into my calculator, and that gives me the 10th term. So it's 40 times minus a half to the power of 10 subtract 1. Probably best to leave it as a fraction. Minus 5 over 64 would be my answer to that. Really important, if r is negative, you have to use brackets, otherwise you're going to get the sign wrong in some cases. EG number 2 is a lot harder. Okay, so with EG number 2, we've got the numbers 3x and x plus 6 form the first 3 terms of a geometric sequence with all positive terms. So if we actually knew what x was, everything would be positive. Find the possible values of x and then find the 10th term of the sequence. So obviously in part B we're going to have to use the same strategy as above, but we are missing the actual sequence itself. So in part A we've got to try and find x. Now the key thing is this is geometric. And with geometric we use the fact that I used there. The ratio between consecutive terms is constant. So if I did that for this sequence, x over 3 and x plus 6 over x, that would be equal because it's geometric. If you attempt to solve this equation, you probably should multiply by the denominators. So times everything by 3x, this goes to x squared, and this goes to 3x plus 18. And if you make x, this is a quadratic, so you take everything to one side and make it equal to 0. This probably factorizes. To give you 2 values of x equals 6 or x equals negative 3. Now I know it says find the possible values of x, and we've got 2, which kind of makes sense, but I'm a little bit concerned because they said everything needs to be positive. So I would actually discount this. All terms are positive for that one, okay? So in other words, the sequence itself is 3, 6, 6 plus 6, which is 12, so on. And you can see that the common ratio for that would be 2, wouldn't it? Now you have to find the 10th term, so un is a r n minus 1. It's really important to write this formula down for every single question, because that's one way to remember it, because it's not going to be given to you in the formula booklet. And the annoying thing is it's an n minus 1 rather than n, so definitely write it down. A is the first term, which is 3, times. Common ratio would be 2. I'm going to include the brackets, but it wouldn't make a difference with this one. To the power of 10 minus 1. And then type that into your calculator. Some of you can do that bit in your head, actually. Powers of 2. A lot of people know them. That's 1,536. And that would be some examples on finding a specific term. If you had to find other things, let's have a look at e.g. number 3. So I'm going to find the sum of the first 10 terms of this sequence. So the first thing you would do is notice, okay, what type of sequence is it, or series? And this is geometric, because if I took the division between consecutive terms, it's always equal to 3. So I know it's going to be a geometric sequence. So I'll state Sn. And it doesn't really matter which one you pick, but the one you should pick, if I was going to stick to the strategy of everything on the denominator is going to be positive, I'd pick this one. Okay, S10. First term is 2. R is 3. Again, you should write brackets around this, but it wouldn't make a difference in this case. It only makes a difference when R is negative. Over R minus 1, which is 3 subtract 1. And if you type that into your calculator, you would get the sum. 3 to the power of 10, subtract 1, 3 take away 1. Always type this in one step, 59,048. Yeah, for the geometric series, if you've got a big R value, a big common ratio, then the sums are going to get pretty big pretty quickly. E.g. number 4. Hardest question we're going to do today. Find the least value of n such that this sum to n terms exceeds 2 million. We did something similar for an arithmetic example last time, but let's just prove that this is geometric. If you took the ratio between consecutive terms, the answer is 2, so that means it's geometric. If you translated this into mathematical symbols, that sum is Sn, because it's sum in n terms, and it needs to exceed 2 million. Or in other words, a Rn minus 1, I'm picking this one to make things positive. R minus 1 is greater than 2 million. And we've got an inequality we're going to have to solve, but it's a lot harder than the previous one because it's not a quadratic one, it's going to be a different one. 1 is the first term. R is 2. 2 minus 1 is greater than 2 million. Okay, let's simplify this. That entire left-hand side, believe it or not, simplifies to 2 to the n subtract 1 is greater than 2 million. And then 2 to the n is greater than 2,000,001. And this is not a quadratic inequality, but an exponential inequality where you've got index form. So you have to make n the subject And the best way to do this is apply logarithms to both sides. It doesn't matter which one you pick. A lot of you think it's base 2, so I pick log base 2, but I just pick log, general log, which is log base 10, is greater than, I forgot the log 2,000,001. And the reason why logarithms is useful is because you can bring this power down using one of the log rules, and it's really easy to make n the subject. And then divide by log 2. And it doesn't really matter which logarithm you pick to whatever base, you should get the same answer for this. Now you'll notice I haven't put the inequality symbol in yet. It's because when I'm solving an inequality and I divide by something, if that something is negative, I have to switch the direction of the inequality. So I'm just checking first, do I need to switch this inequality? Is this a positive number or a negative number? Okay, it's positive, so I can keep that as it is, because log 2 is positive. Right, n needs to be greater than log, doesn't matter which base you pick, it's going to be bigger than 20.93 ... And in the context of this question, n needs to be a whole number. So the first whole number, which is bigger than 20.931, would be n is equal to 21. N would be equal to 21, and that is pretty much it for that. Okay. Now the questions I would like you to complete, if I can find them quickly. It's going to be 2 exercises again. Okay, if you look at exercise 3C, which is on page 69, and if you do the evens, and for the questions where there's multiple parts, you can just do the even parts for those as well. And then you need to go to exercise 3D, and again, if you do the evens for that, that would be good. That's on page 72. Now there are 2 things which I haven't shown you yet from the first 4 subsections from this. So just in case they crop up if you're doing any extra revision, I haven't shown you how to prove 2 things. You haven't seen the proof of the sum formulas for either arithmetic nor geometric, so you haven't seen either of them. So that will be done next year. Okay, so just in case you do some revision on geometric and arithmetic stuff, you think, well, why are they asking me to prove something which I haven't seen this proof? It's just you haven't been shown it yet, but you will be shown it next year. Right, that's pretty much it. If you have any questions, let me know in the Teams chat.